Okay, so let's continue here with part two. We talked about the three main types that we had, the status column, the last modified, and the change data capture. So let's take a look at each of those in this particular video. So here's an example of a table with a status column. You can see that it's just a map. This is actually let me get my pen here. This status column's definition is just a CAR1, char1, care1, as my friend Dan calls it, care. I never understood that. Um, so you could see like an N would map to the fact that there's no change. So we could actually fairly simply, fairly easily write a query that said only show me the rows that I need to add. So we'd say select all from my table where status equal I. And then from that I know those are the rows that need to be inserted into the destination. Now you might be asking yourself, how does all of this get populated? What's the process that does this? This is generally going to be some set of triggers. So you would have a delete trigger for marking a virtual delete, a ghost delete that you see here. So this particular row would be a ghost delete. We'd probably have a filter on any applications and reporting that goes against this table that says do not show any rows that have a status of D. And so you'd have a delete trigger to do that. Then you'd have an insert trigger to mark I, or what you'd have is a default value that's bound to the letter I. And that way any new row that gets inserted automatically gets an I. And then the U would be handled from an update trigger. And so you just say if any column is updated, then I want the U to be placed into the status. And then it's also important to have a process to come back through here and reset these statuses after you've done your synchronization. So for example, at 11 p.m. tonight, we synchronize the database. Well, then we need to go back to the source and change every one of these to be an N, because now there is no change. The source and the destination are in sync. So you've got to have some way to go back to the source and maintain this status column. So this is actually a fairly common technique, particularly when you have to load large data warehouses. You'll find that a lot of the tables will have something just like this, particularly those with a lot of text columns in them. Now, a last modified or a modified date column, I didn't put an example of that. That's probably so easy you can kind of understand what that would be. I could just write a query. I could say select all from my table where last modified, greater than September 1st, 2010 at 000, which would maybe be our last sync date. And then I've got all of the rows. Now the problem that I have in a situation like this is, gosh, I don't really know, was it added or was it updated? And so if this is your only marker that you have, often you will delete any rows at the destination that match the primary keys in this set and then simply replace them with this set of data. So this, for example, would become your source here. And you would use it as the canonical set of data. You would go delete any destination that had the same primary key as your source did, and then simply do now an insert. That way you'd make sure you had everything. It would be probably a little too messy to do an update statement. Now the negative in this is, how do you deal with deletes? Like for example, how do you deal with a situation where a row has been deleted from the source? What's the value for last modified column of a deleted row? I can't even say that without laughing. I mean, you've deleted the row. Of course, there's no value, right? There's no row for which to have a value. So that's the challenge when your only marker is a column like a last modified or a modified date. So I asked that same question here just so you'd have it in your notes Now, SQL 2008 does have a new feature called Change Data Capture. And Change Data Capture is really, really awesome. It's got its own set of functions and tables, and they mimic the source tables that you build them on. And then you could just query and say, hey, show me only the changes since this date. Show me only the new rows. Show me all of the deleted rows. Very, very awesome, completely meant for this specific situation for doing incremental updates. Okay, so you could just filter, it's awesome. However, the only negative is that this has to be using SQL Server 2008 as a source. So if you're going to a SQL Server 2008 database as a destination, this can't help you. This is not going to be what you're going to work with. Like, for example, if your source data is in Access and your destination is SQL 2008, Change Data Capture isn't going to help you. You have to be using SQL 2008 as a source, and then it's actually fairly easy to do that. And by the way, this is only available in the Enterprise Edition. It is available in the Developer and the Evaluation Editions, but those are not for production. So you got to have your source be an Enterprise Edition SQL Server. Now, in truth, if you're loading a real live data warehouse, this is probably what you have anyway. Your source is likely to be a relational data warehouse that stores all of your data prior to processing the cube, and because there's so much data, it's likely to be on a SQL Server 2008 Enterprise Edition server, and then it gets a little bit easier to do that. But that's the idea of Change Data Capture in SQL Server 2008. Now let's talk about how to actually accomplish our incremental loads. Okay, so we just got through talking about the things that have to be in place to do an incremental load, or the things that we can do. You know, we could add a last modified column. We could put a status column at the source, or we could do change data capture. Let's now talk about bringing SSIS into play. Everything we've talked about so far was not SSIS. They were just architecture. So now we're designing our SSIS package. What are my options? Okay, well, there's two basic approaches. There are other approaches, of course, but these are the two approaches that I see people using day in, day out. Number one would be a series of the execute SQL tasks. Okay? So you basically, this is going to say, I want to take the data from SQL 2000, for example, and I want to insert the new rows into SQL 2005. If you have linked servers to both servers, if you're able to write a query to access both servers, the execute SQL way is a great set-based way to accomplish this. Okay? You'd have up to 3 execute SQL-based tasks, 1 to perform the inserts, 1 to perform the updates, 1 to perform the deletes. To be able to use the execute SQL task for this, that means that your source has to be SQL. You have to be able to write SQL against the source. Well, is your source always SQL? No. Many times you're exporting from something like a mainframe, and you're given a text file with status column still, but it's in the text file. Execute SQL task won't help you in that case. And so the most flexible option is using the conditional split transformation with a data flow task. So you use the data flow task to define your sources. You bring them in, you take and put it into a conditional split. And now in our conditional split, we say, okay, if the value of status is I, then I want to perform an insert. If the value of status is you, then route this to the update statement. And I'd use an OLEDB command for that, for example. If it's a delete, let's do an OLEDB command to perform a delete at the destination. Okay. So I tell you what, let's do that. Let's take a look. Let's stop lecture mode here. Let's come back in the next video, and let's do the data flow task with the conditional split. And what we'll do, we'll start out from, we'll build a database, we'll build the tables, we'll populate it, we'll do the whole thing to make sure you understand the whole thing.